Hi guys, this is Dr. Muhammad Usman and today I am back with another video on this topic of graph and trees. Basically in this video we will be talking about what are the graphs and what are the basic types of these graphs and what is different between graph and trees. So if you haven't liked our channel yet, go today to my YouTube channel and like and subscribe to it. So basically what is a graph? You can see that a graph is a very simple thing and it has nodes, and these nodes are linked together. And you have similarly studied this graph in your programming language. You have to connect these two nodes and you can store data at different nodes. So when we are talking about the graphical visualization, everything can be a graph. Similar, like we can just make different visualization. We can pinpoint different people connected on a social network, the railway tracks, the Google Maps, the brain signals, the mind language. So basically everything can be a graph, and and we store data in form of linked list and graph, and we have already worked on it. So basically when we are talking about the graph, we can ask different questions, that how does the brain organize itself to achieve a function, and how we can disseminate the knowledge among the online communities, how the two graphs are similar, and what social entities or social network can be together, and what social network can be used by different terrorists or different organizations. So basically by understanding the graph and trees working, we can work on different social and different technological problems, and we can find out that either which is the best solution for our analysis, and what we can find out through our graph and trees hierarchy. So when we are building up the graph, the primary concern of the graph is the spatial arrangement of the nodes and link. It depends on us that how we can arrange these nodes, and we can just put different things together depending on the data available to us. So some of the time the goal is to effectively depict the graphical structure, including the connectivity, patterns, partition, cluster, and outliers, and some of the time we just want to show all the data. So if you are working on all the things together and you want to show all the things, then something like this will be in your graph, and this will be like putting all the things in one perspective. But if we are similarly talking about displaying all the data in one visualization, so this will be some kind of graph that will be displayable. So that depends on us, that how we can use the graphs and how we can make up the graph and we can connect them. Similar, like the trees are also similar to your graphs, and we can just differentiate between the graph and trees by four major tree visualizations. On number one, we have indented list, then node linked trees, then layer diagram, and tree maps. Talking about the indented list, it is the basic, very simple thing that you can see in your My Computer, and you must have seen this image in your systems, and you have worked on. And it is just placing your all the items along the vertical space rows, and you can just move the scroll bar and you go over the different values, and you can just click the plus sign and you can go into the next folders. So we have all gone through this kind of indented list, and we have used it in our real life, in our system, in our Windows. So it is commonly used as a component in the interface, and it also goes in the breadth and depth content for the space. And but the problem over here is one, that when there are many items, then you have to go into different scroll. Like you must have seen, if you have folders, and in other that we have more data, more folders and more folders, then this scroll bar will become very small, and you have to go into breadth and depth to find out the actual value of the element. On the second, we have the node link tree. It is very similar to, like, we have the root node, and these are distributed evenly by space, and they are connected straight by the curved line. It is also based on the 2D approach of breaking apart in breadth and depth. And we also called it Rhine-Gold-Tilford algorithm, which achieves the linear time when we are making up the node link trees. So nodes are distributed among the different space, and we have different leaves, and we can just move from one leaf to another leaf. Also, node link trees are of different, like we have a node link tree in form of radial graph, and it has different center points, and these center points have different elements and different nodes, and this can have further nodes. So it just depends on the radius that encodes the depth of this one. So we can also convert them into further the thread arcs and phyllo trees. So when you are working on the D3 and you are working on different visualization, you can just find out that how can different node link tree we can use in everyday life. So it is basically similar to our normal visualization techniques which we are using in our visualizations, and when we are building up our visualization and working on them. The third one we are having is the layer diagram. It is basically used for layering, adjacency, and alignment of different elements. It is just similar to the node link tree, but the difference is very small over here. Like we have to work on different nodes, and we have to just put in one alignment. Like we have to first put one node, then we have to work on the second part of it, and then second component, then third component. So basically, if we find out the difference between the node link tree and the late diagram, it is just simple. Like we have just display over the nodes are moving in one direction, but in the form of this one, it is moving in the other direction. Like we have to put the content in the simple normal space. So late diagrams are the simple one, like the node link trees, but the difference is like it is moving in one direction, and it can just move from the one center point to another center point. So I have two examples over here, ICEL trees and sunburst. Last one we are having at the tree maps. Tree maps are the similar to the late diagram. They are used for encoding the hierarchy and the visual spatial, or it is used for the space filling technique. So basically, tree maps will be containing a single view of the entire tree, and it is easier to load up your data or using the small or large node. But the problem is that it is difficult to read, and it will not also give you the exact location of the different elements. Like we have seen that we need some position of the elements when we are building up our visualizations. And when we combine both of them, we form into a hybrid kind of approach. Like if we have using the node link tree and plus the late diagrams or the tree maps, then we can go into different type of matrices which have different elements, and we can just use together them. So hybrid graphs are those ones which are using the combined techniques of different elements. So I will ask you what you see in this graph. It is the animated radial graph, and I have this one over here. What you can see in this one, you can answer in the comments that what you find out in this graph. Similarly, like I have this one, this is called Sugiyama style or the late diagram. It is the layout of the ICALI graph. So you can just see that we can just convert different matrices into different graphs, and there is just a little difference between all these types, just the styles and just the working, and there is no much difference in this one. So I will just conclude over the basic matrix and node link difference. Like matrix doesn't require learning, and the node link you are already familiar. In matrix there are also some more differences, like matrix supports the dense graphs, but node link doesn't support the dense graphs, and matrix doesn't support the sparse graph, but node link supports the sparse graph. So basically there are the simple differences provide you the difference between the matrix and the node links, and which are used in our normal visualizations in our daily life. So this video was up to here, and you can just go to my YouTube channel and like and subscribe to stay updated to my different videos channel. And the process for the training certificate is as follow. So what you are waiting for? Go to my YouTube channel and like